Good day. Today I'm going to introduce you to something I consider to be revolutionary for our FPV community and actually could have significant positive impacts well beyond our FPV community. You see, up until recently, in order to get smooth-looking cinematic type video from your FPV drone, you need to strap an expensive GoPro or some sort of similar type camera on board that has electronic image stabilization, or process your GoPro footage with Real Steady Go, which does an excellent job at a reasonable price, but it is an additional cost. Today I'm going to show you how you can stabilize FPV video without using an expensive external camera strapped to your quad, which means you'll also save weight and help keep your micro FPV drone under the 250 gram limit if that's important to you. And it's free. What's more, it'll work with just about any camera. It's called Gyroflow. It's an open source project being developed by Elvin Chen, whose website I'll link to in the video description below. Gyroflow is a gyro-assisted free video stabilization software tool for aerial videography and other stuff. I'm going to show you the few things you'll need, walk you through the simple FPV video stabilization process, and demonstrate the results with FPV video stabilized from both the Byte digital FPV system with a Foxeer Digisight camera, and also a flight with an analog Caddx Tarsier V2 dual lens FPV camera. If this sounds good to you, make sure to give the video a thumbs up below and subscribe to your TMac FPV channel, your home for your journey to better FPV fun, flights, and racing stuff. The first thing we want to do is go out and fly and record our FPV flight video and Blackbox log file. Before we do that, we need to make sure we have enough space on our Blackbox flash memory to record our Blackbox file when we arm our quad, and that our quad is set up to record the Blackbox file. So we need to connect our quad to Betaflight, go to the Blackbox tab, and we want to make sure this is set to our correct Blackbox logging device. In my case, it's onboard flash. Our Blackbox logging rate should be set to 500 or 1000. I'm going to go with 1K. And since we're not going to be doing any Blackbox analysis, we can have our Blackbox debug mode set to none. If you've changed any of these, remember to save and reboot. Next, we want to make sure we have enough storage space. So we're going to erase flash memory. Now we're ready to fly and get some good video and a Blackbox log file to go with it. Okay, once you've captured your flight video to your onboard SD card using your Caddx Tarsier or similar type camera, or your Byte digital FPV system with the SD card on the Byte module, go ahead and save it to a folder on your computer. We'll be using it here in just a minute. Now we're going to want to upload our video file to Blackbox Explorer. Not to do any analysis, but just to synchronize the video to our Blackbox log. But before we're able to upload our flight video to Blackbox, we need to make sure it's in the proper format for Blackbox to use. If we go to this Blackbox GitHub site, which I'll put a link to in the video description below, we see Blackbox likes files in the MP4 format. Our Byte video file from our Cobra flight is a .ts file, so we'll need to convert it to an MP4 format. To do that, we'll just follow the steps outlined in this Blackbox GitHub site for using the Handbrake video converter. A link to download the Handbrake video converter for free is in the video description below. First, we'll just drag and drop this over here. Now, if this shows up as something different than a .mp4 format, such as an M4V format, what you need to do is change that to MP4 under Tools, Preferences, Output Files, and this MP4 file extension. It may be set on automatic. You want to switch that to always use MP4 and then go back. You may have to restart it, but with that, it should provide a .mp4 file extension. And then you look where each of these red bars are. You want to make sure that it's H.264. The frame rate is same as source, which makes it a variable frame rate. And then one thing I want to point out is at times, I've had to type this key int equals 1 down here in the advanced options box to make it work for me. Check out the dimensions, and we want to save it to the same folder we had the original version in, just to keep track of it. So to do that, I'm going to click on Browse, put it in the same folder, and click Save. Then all we have to do is start encode. And you'll see the status bar down here at the bottom. It usually takes a couple minutes. All right, and down here we see our status bar says Queue Finished, and it's converted our .ts file into a .mp4 file and saved it to the same folder as our original flight video. Now that our flight video is ready, we need to grab our Blackbox file from our quad's Blackbox flash memory or onboard SD card logger. I'll be using flash memory on both my Rattler and Cobra micro FPV drones. So we connect to Betaflight and go over here to our Blackbox tab. We activate mass storage device, and that'll bring up a drive for our quad's flash memory, Betaflight onboard flash. Grab the Blackbox file that corresponds to our flight video we just saved. If your flight video was the last flight you accomplished, the Blackbox file that corresponds to it will be the one with the highest number next to its name. In my case, it's 2, and we want to copy that and save that Blackbox file to the same folder as our flight video. Here. Alright, so now in this same folder, we've got our flight video in MP4 format from our SharkBite digital FPV system and our Blackbox log file that corresponds to that flight. We're now ready to create a CSV file using Blackbox Explorer with these two files. And while we're in there, we might as well do our best to synchronize the flight video with the Blackbox log file, which I'll show you a very simple way to do that. So we open up Blackbox Explorer, and from here we upload our Blackbox log file. Once that's uploaded, we click over here to open log file / video, and then we just grab our flight video with the .mp4 extension. It's actually uploaded, we just don't see it here at this point in the file. So I'm just going to click down here, and we see that the video is uploaded. We're going to export a CSV file to the same folder we just got the flight video from, but before we do that, I want to synchronize the flight video with the Blackbox log file as closely as possible. This will give us an offset time value up here to work with in Gyroflow. If we go back to the beginning of the file by clicking this button, we see Blackbox is telling us when it thinks the arming beep begins. And we want to synchronize that with when we actually arm our quad. The easiest way I know how to do that is to arm the quad in front of the video camera at a safe distance away so we can actually see it. Of course, keep safety in mind and do not do this on a brand new builds made in flight. We're going to scroll the video by pressing and holding our left mouse button and dragging the video to the place where I flipped the arming switch on my quad. And I've got this green arming switch here. When that goes all the way in the down position, I've armed the quad in the video. Right there. Then we just click on this button up here that says Start Log here. Watch when I do that, this offset time will change. We see the arming beep begins line has moved to when I've armed the quad. We take note of this offset time, 24.021, and actually write it down so you don't forget it, 24.021, and then we click on Export CSV and save it to the same folder with your flight video and Blackbox log file. That's it. Now we're ready to use Gyroflow. To get the Gyroflow free video stabilization software tool, go to gyroflow.xyz. And if you're interested in supporting the Gyroflow project, either through coding, testing, or through a donation to help out development, there's a donate button over here. And when you click on it, it'll explain how you can help out. Going back, we want to download the executable for your system. In my case, it's Windows. And also the lens presets zip file to a folder on your computer. You want to extract the zip file, and once you do that, you should have the camera presets folder and the Gyroflow executable file. To begin using Gyroflow, we just double click on this file. This brings up the command window, and you want to position it over here not to take up your full screen, because another window will pop up, which is your user interface. Here, this is the window that we'll be working with. We've got these various buttons here as options. To get the latest status on the Gyroflow project, click on this Git repo link down here, and it'll show you the status of what's currently available and what's being planned for future releases. For the purpose of this video, we're only going to be concerned about this button, Video Stabilizer. However, keep this button, Camera Calibrator, in mind because I'll mention it again here shortly. To start our video stabilization process, we just click on Video Stabilizer. Then we upload our MP4 flight video file we saved to our folder earlier. Here. Next, we upload our CSV file we exported from Blackbox Explorer to that same folder, CSV. Now we want to click on this Open Lens Preset button and select the correct lens preset file for the FPV camera you use during your flight. And that'll be in this camera presets folder that you downloaded from the Gyroflow website. So we open that folder up, and within this camera presets folder you extracted earlier, you should have several brand camera folders to choose from. Within your camera brands folder is where you'll find a lens preset file for your camera to click on and load. This is important. If you don't see a lens preset file for your camera, that just means one has not been created yet. If that's the case, you have a couple options. You can either make one yourself by using that camera calibrator button from your user interface window I mentioned earlier. I'm not going to go through that process in this video. I may do another video on how to accomplish that sometime soon. However, Elvin Chen has captured that entire process in his detailed video, which I'll link to in the video description below. Your other option is to ask around and see if someone else may have a preset file for your camera. However, you will need a preset file or this process will not work. The great thing about this process is you can create a preset file yourself, basically for any camera you're using, whether it's an FPV camera or not. So for our SharkBite flight video, I'm going to select this Foxeer folder to select the camera preset file for our Foxeer Digisight Nano FPV camera. This Foxeer folder and Digisight preset file at the time you're watching this video may not yet be in the presets folders you downloaded from the site. If that's the case, no worries. I've created this Foxeer Digisight Nano preset file myself, and you can grab it from the video description below. To process our Rattler flight video with the Caddx Tarsier, I'd go to the Caddx folder and click on this Caddx Tarsier V2 camera preset. Once we select this preset file for our camera, Gyroflow is going to check to see if it matches the flight video we're trying to process down here. Then we just start inputting some values. We input the approximate camera angle we had during our flight here. For this slow flight on the beach, I think my camera angle was probably around, 10 to 15 degrees. I'll just put in 10. Then next, we go to our Sync Stabilization tab, and here we enter the initial rough gyro offset number that we wrote down when we synced our flight video up with the gyro data in Blackbox Explorer. If I remember correctly, which I do since I wrote it down, it's 24.021. For auto sync timestamp 1 and 2, we're going to go back to our .mp4 flight video and pick two different times toward the beginning and end of our flight, which have some movement or shakiness to them. We're going to put those times in these auto sync fields in units of seconds. So I'm going to go to our flight video and pick a time at the beginning of the flight, which appears to have some movement in it, like 34. And then closer to the end, maybe. How about there? 34 and 60 and 41 is 101. 34 and 101. So I'll put those times here, 34 and 101. And then for most flight videos, this number of frames to analyze per slice, we can leave that at its default value. This sync search size in seconds is just the time window we're going to give Gyroflow to look around our initial rough gyro offset number you put up top here. Since we've already synced our video and gyro using Blackbox Explorer, our window doesn't need to be very wide. I'll just put in 15 seconds for our demonstration, and that's more than enough. You can experiment with the smoothness and FOV scale to see if it improves the outcome of your video's processing. The FOV scale is how zoomed in the resultant video is going to be. For now, I'm just going to leave these at their default values and click on Apply Settings and Compute Sync. While I do that, we'll watch the command window over here to see if it's processing correctly. This can take a few minutes, and a few graphs are going to pop up showing you where Gyroflow is calculating the sync points. With more experience, you can analyze those graphs that do pop up and decide if you want to override Gyroflow's calculations manually with your own or not. For now, I'm going to trust Gyroflow's calculations, and for each of the graphs that do pop up, I'm just going to close them out. So we'll apply settings and compute sync and watch what happens over here. We should see some graphs pop up eventually, and this can take a few minutes. Once Gyroflow has completed its sync calculations, the delay for sync 1 and sync 2 fields will be populated with some values. It's calculated an estimated offset, and here's the first graph that's popped up. Down here, it's calculated the initial offset at 24. You can use this pan button down here to zoom in if you want. Move it around. I'm just dragging my mouse keys. But as I mentioned, we'll just close these graphs out. It's showing the estimated offset at 24 and a better offset of 24.024. which is pretty much the same as what we had put up here as our initial rough gyro offset. We'll close this graph out, and we'll close this graph out. These show that your various axes. And down here now you see that it's populated these values for the delay of sync 1 and sync 2. From here, we just go to the Export tab. The output crop fields are going to be populated with the original file size of our video. And we want to make these values somewhat smaller than the original to reduce or eliminate the amount of black borders that we see in our processed video. You'll just have to experiment with what works for you. Since these are 16:9 aspect ratio, I want to change these to 1024 by 576. And I'm going to choose to change the output upscale to a value of 2. And these next fields are the video export start and stop time in seconds. The start of the video is obviously going to be at 0, and we just need to put the video's end time here in seconds, which Gyroflow auto-filled in for us. If we go to our original flight video and scroll to the end, we can see that our flight time was 2 minutes and 12 seconds, which is 132 seconds, which is exactly what Gyroflow auto-filled in for us. Down here, I've noticed on my computer, I do need to put in YUV420p, YUV420p, in order for it to work on my computer. Then we just click on Export Stabilized Video and select a place to save it, such as the folder that we've saved our other files to that we've been working on. As it's working, we can watch the display preview during rendering. I'll name the file SharkBite Gyroflow Stabilized Video and click Save. And over here we see it processing, and here's our display preview window. You'll see that we've still got black bars, even with our output crop size of 1024 by 576. To take care of these, we're just going to put it in our favorite video editor and zoom in to the point where the black bars disappear. In my case, I use the free version of DaVinci Resolve. So once this video has been processed by Gyroflow, the only thing I'm going to do to it is take this file, which it produces, and stick it in DaVinci Resolve and zoom in. I've used these exact same steps to process our Rattler flight video, and the only thing I did differently was I used the Caddx Tarsier camera preset file instead of the Foxeer Digisight preset file. The amount of time it takes to process the video is dependent upon the length of your flight video. This could take several minutes. It saved our exported stabilized video to the folder with our other files. So now let's take a look at the stabilization results for both flights with the Foxeer Digisight Nano and Caddx Tarsier cameras using a before and after Gyroflow view of each. Let me know what you think of the results down below. Thanks for your time, and I'll see you next video. Clear skies, friend.